Hello everyone, today we are going to learn about math, especially about function. This material will be presented by Farhan Furqan, Laude Muhammad Zulfan Fadil, and me myself Nur Mulya Dwi Prasetya, and Silvester Nathanael is Dorigin. Today's agenda is to know more about domain and range of function, and uneven function, and contrast between domain range function and odd and even function, also about the definition and example of each function in the real life. So, definition of function is a relation from a set of inputs to set of possible outputs, where each input is related to exactly one output. This means that if object X is in the set of inputs or called the domain, then the function of f will map the object z x to exactly one object fx in the set of possible outputs. What is the domain of a function? A domain of function is all the set of value for which a function can be defined and called as the natural domain. For example, fx equal x squared. X can be defined as all the domain from the real number. A second example is ft equal to the power of t, where t can be defined as the domain from all the real number. And the third example is fz, where equal square root of z. Since square root cannot be a negative, this means that z is greater than 0 and the domain is from 0 to the infinity for all positive numbers. As you can see from the graph, it starts from 0 until it goes to the infinity. Example of domain of function in real life. So this is a case where Peter needs to fill up his truck with gasoline to drive to and from school next week. If the gas costs $2.79 per gallon and his truck only can hold maximum of 28 gallons, so what is the domain? So if your answer is the number of gallons of gas that Peter purchased, you are correct. A range of function is the set of all output value of a function. It goes from domain and the process in the function in the range as the output. For example, when the function fx equal x square root is given the value x equal 1, 2, 3, and so on, then the possible outcome is equal 1, 4, 9, and so on. It's because fx can define as x times x or x times itself. What is the example of range of function in the real life? Here are the example where Pablo charged $20 an hour to teach salsa dancing. What is the range of how much money Pablo can make off from salsa dancing? Since the range is money that Pablo can make by teaching salsa dancing, so the possible range is from $0 goes to the infinite dollar.
Even of a function. A function is even when function x equals f minus x for all x. In other words, there is a symmetry about the y-axis. They got called even function because the function x the power of 2, the power of 4th, the power of 6th, the power of 8, and etc. behave like that. Odd of a function. A function is odd when the minus function x equal f minus x for all x. Note minus in front of function x divided by minus function x, and we get Dorigin symmetry like this. They got called odd because the function of x, x the power of third, the power of fifth, and the power of seventh, and etc. behave like that. Misled by the names odd and even. They are just names, and the function does not have to be even or odd. This is the curve. The function of x equals x to the power of 3 minus x plus 1. It's not an odd function, and it's not even function either. It's neither odd nor even. Both of even and odd of a function in the real life. If we throw a ball up in the air and place our origin at the top, the distance above the ground is an even function, and the velocity is an odd function. Baking a turkey heats the oven up then constant for 6 hours, then the oven cools off. If you place that origin at 3 hours, you have t as an even function. Finally, I'm an elevator. It accelerates to start moving, then constant speed, then negative acceleration to stop. Again, origin is the middle, an odd function.
Comparison and contrast between domain and range. Given function fx is equal to x plus 2. So if the input is 1, you just replace variable x become 1 and you will get this result, which is 3 as the result. It is the same way if the input is 2 or 3, you will get this result 4 and 5. So in this case, domain is all the input or numbers inside this bracket, which is 1, 2, and 3, while range is all the output or all the result, which is 3, 4, and 5. Next, state the domain and range of the following relation. Is the relation a function? The number are 2.-3, 4.6, 3.-1, 6.6, and 2.3. In simple terms, domain is x and range is y. So the domain is 2, 3, 4, and 6, while range is -3, -1, 3, and 6. The given set indeed represent a relation because x and y are being related to each other. So how if z contains 2 points with the same x value, like 2.-3 and 2.3? So since x is equal to 2, give 2 possible destinations, that is 2 possible y values. So this relation is not a function.
Compare and contrast both odd-if function. They are separated by 2, which is odd function and even function. Even number function can be present in positive or negative number. For example, function x equal to x in the power of 2 and function x equal to minus x in the power of 2. Odd number also can be present in positive and negative number function. For example, function x is equal to x in the power of 3 and function x is equal to minus x in the power of 3. Even number function. This is the graph of function x equal to x in the power of 2. It makes curve that goes to the top, and the domain is minus infinity and infinity, and the range is 0 and infinity. This is the graph of function x equal to minus x in the power of 2. It makes curve that goes down, which is the opposite of the positive function, and the domain is minus infinity and infinity, and the range is minus infinity and odd number function. This is the graph of function x equal to x in the power of 3, can see that it starts from down and go to the top. So the domain is minus infinity and infinity, and the range is minus infinity and infinity. And on the right side, this is the graph of function x equal to minus x in the power of 3. We can see that it is the opposite of the positive function. It starts from the top and goes down, and the domain is minus infinity and infinity, and the range is minus infinity and infinity.